Hello, friends. Today we're going to talk about function notation. And function notation is not really totally new to you, but it's something that is just a little bit different than what we've seen before. So, function notation is a different way to write an equation. So this is an equation we're used to seeing, y equals 2x plus 7. And you know the way that this works is we can plug something in for x and it'll tell us what y is, or we can even plug something in for y and solve for x. We know how to do both of those things. But what function notation does is it rewrites this as f of x, that's how you read that, f of x, equals 2x plus 7. So f of x represents, this would be like in a long fancy way of saying this, we would say this is a function, this is a function of x that is 2x plus 7. So we're going to look at lots of examples, so don't worry about that. But just know that f of x, f is not a variable. It's just a notation. And f of x is it's exactly the same as having a y there. Like these are completely interchangeable and there's no real difference. So don't let this make you think that it's f times x or that f is a variable to solve for. It's nothing like that. So f of x and y are completely interchangeable, but in function notation, so in f of x, x is the input and f of x is the output. So like y would normally be the output. So function notation is specifically useful for finding a value in the range that corresponds to a certain domain value. So we talked about domain and range. So x's represent the domain, and f of x, that's the same as y, so that represents the range, okay? And so if f of x equals 2x plus 7, then what would f of negative 3 be? Okay, so if we look at just the function notation parts, so f of x, and then we have f of negative 3. What did we do here? What's the difference? We replaced x with negative 3. So if we replaced x with negative 3 here, then we also need to replace x with negative 3 here. So f of negative 3 equals 2 times negative 3 plus 7. And I've told you this before, but anytime that you're substituting things in for variables, always put these parentheses where the variable was so that you can be 100% sure that you do all the right steps. Okay, so 2 times negative 3 is negative 6. Negative 6 plus 7 is positive 1. So we get f of negative 3 equals 1. And this is the same as saying if x is negative 3, then y is 1. That would be the same computation. This is just another way of writing it. So for the first 6 problems, they're grouped, and our instructions tell us to use these same 2 functions for all 6 problems. So we said that function notation was f of x. So what in the world is g of x? Well, the truth is, function notation doesn't have to be an f. So g is another function. All it means is that this function is different than this function. It's just a way to tell them apart. Just like x is a variable and y is a variable, but the fact that they're different letters tells us that they are different variables. So since these functions have different letters, we know that they are different functions. So this number 1 asks for f of negative 9. So since we're using f, we don't even care about g. Ignore it for this problem. And we are going to take f of x and we're going to plug -9 in for all the x's. So f of -9 equals, and then I'm going to rewrite this with parentheses instead of x's, and then just go back in and put -9 in any parentheses that I have. Okay, so then we're just going to solve. So we get f of -9 equals -5 times -9 is positive 45 minus 14. F of -9 equals 31. And that's it. You're just plugging a number in for x and solving. So this process that we're doing is called evaluating functions. Okay, we are evaluating functions in function notation. All right, this problem also uses the f function, so we don't care about g, we don't need it for this problem. And it's f of 3/10. So everywhere there's an x, we're putting 3/10. So f of 3/10 equals -5 times x minus 14, but our x is 3/10. And -5 times 3/10 is -3/2 minus 14. And then we get f of 3/10 equals -31/2, or you could say -15.5. Either one is fine with me. And that's our answer for number 2. Okay, so number 3 uses g, so we don't need f. So we're going to rewrite this as g of 0.4 equals, and like I did before, everywhere there's an x, we're going to put parentheses. So -x squared plus 9 times x minus 1. And then we just put 0.4 everywhere there are parentheses. And this is important, especially because this negative is outside of the x. So if we, just for an example here, if we had -2 squared, you may question whether this is -2 times -2, or is this -2 times 2. Okay, so this is saying that whatever x is, you square it first, then you make it negative or the opposite of whatever it is. Okay, so that was a lot of explanation for a mistake you hopefully won't have to make. But here we go. So we have to square it first. So we're going to, and then make it negative. So 0.4 squared is 0.16, but that's going to give us a negative 0.16 because of this negative. Then we have 9 times 0.4 gives us 3.6 minus 1. And we should get g of 0.4 equals 2.44. All right, we're using g again, so we don't need f. So g of -7 equals -x squared plus 9 times x minus 1. And then we put -7 in for all of these problems. Now, again, this is where the parentheses come in handy, because if we had just written this out, we would have written -7 squared plus 9 times -7, and you probably would have put in parentheses there anyway, just out of habit, minus 1. But what does this look like? That looks like it should be positive 7 squared, right? Like you really want to make those two negatives be a positive, but that's not the case, okay? Our function tells us we have to square x, and x is -7. So we have to square -7. And so -7 times -7 is positive 49. And then we make that negative. So we get -49 minus 63 minus 1. And that will give us g of -7 is equal to negative 113. Okay, so this one has two parts. We have f of 1 minus f of negative 4. And the easiest way to do this is to solve separately for f of 1 and f of negative 4, and then subtract your answers. So that's what we're going to do. We don't need g at all because these both are f functions. So f of 1 equals negative 5x minus 14. And we put 1 where the x was. So that's going to give us negative 5 minus 14. And we get f of 1 equals negative 19. So remember, we're not done yet. We still have to solve for f of negative 4. Negative 5x minus 14. And then we put the negative 4 in where the x was. That gives us positive 20 minus 14, and we get f of negative 4 equals 6. So now we're going to go back to our original equation. F of 1 minus f of negative 4 equals negative 19 minus 6, which is negative 25. And that's your answer. Okay, this one looks a little more tricky, but it's not, okay? So think about order of operations. You have to do what's in the grouping symbols first, right? So we are first going to solve for g of x, or g of 12, sorry. Then we're going to multiply that answer by 2. So we don't need f. We're going to do g of 12 equals negative x squared plus 9x minus 1, and put our 12 in where our x's were. We get negative 144 plus 108 minus 1. And that is going to give us negative g of 12 equals negative 37. But we want 2 times g of 12. So 2 g of 12 equals 2 times negative 37, which is negative 74. So numbers 7 through 12 follow that same kind of structure. So I'm going to let you do numbers 7 through 12 on your own. And there are answers for you to check your own work. But then number 13, it gives us a function, f of x, but instead of telling us what x is, it tells us what f of x is. So what this means is we're going to replace f of x with 34. It tells us that's what f of x equals. And then that must equal 3x plus 19. So then we are going to solve for x. So subtract 19 from both sides, and we get 15 equals 3x. Divide both sides by 3, and we get 5 equals x, which we will rewrite as x equals 5. And that's our answer. So that's really not too bad, okay? So it told us what f of x is. We plugged that in, and then we solved for x. So I'll let you try number 14 on your own. It's a very similar problem, but I want to talk to you about number 15. Number 15 is a word problem. I know you guys love these. They're so fun. And I'm going to do number 15 for you today, even though there's not a problem on the guided notes like it, but there is a problem on your practice tomorrow like this. So this problem will help you with tomorrow's homework. Or not homework, but practice. I guess everything is homework right now, right? Okay. Owen paid a landscaping company $108 for an initial lawn treatment. So the first time this company came out, it cost $108. But then to keep it up, he's paying $74 per month every month for them to keep up his lawn care. So the function P of T equals 108 plus 74t. represents the total amount of money he will have paid after T months. So we can think of this as the price after this much time. Okay? So P of T is how much money he's paid after T months. All right, so this asks us to find P of 24. So we're going to take P of T and rewrite it. 108 plus 74 times T, but T is 24. This is going to give us 108 plus 1,776. And then you add those two together and we will get P of 24 to equal 1,884. But we need to know what this represents. So if we decided that the function is the total amount of money paid after T months, this means that Owen paid $1,884 over 24 months for his lawn care. Okay, so it's just as important to be able to interpret your answers as it is to be able to interpret the problem. So part B of number 15 asks us, how long has Owen been receiving lawn care service if he has paid a total of $2,994 to date? So this says how long. That means we need to find the time that he's been going. It gives us the total price. We need to find time. So that means that P of T is going to equal 2,994. And we're going to solve for T. So first we'll subtract 108 from both sides. And that'll give us 2,886 equals 74T. And we'll divide both sides by 74. And that will give us T equals 39. But what does the number 39 mean? It asks us how long. So is it 39 days, 39 years, 39 weeks? It tells us here that T is time in months. So this is 39 months. All right. Number 19 is the last problem that we're going to do together on this one. And I'm doing it because I feel like you guys might need a reminder about binomials. So binomials are like expressions with two parts. So this one has a minus 3. That's two pieces. So this is g of a minus 3. We don't need f of x because it only asks us about g. So g of a minus 3 equals x, and remember we just put parentheses in for x, squared minus 5. And x is a minus 3. So we have a minus 3 squared minus 5. Okay, when you square a binomial, that means you multiply it by itself. So a minus 3 times a minus 3, and then minus 5 on the end. So to multiply two binomials, we use the FOIL method, okay? And this is I'm going to bring this over to the side and do it on its own. So we have a minus 3 times a minus 3. And the FOIL method tells us how to multiply all of these together. So FOIL. F is for the first terms. So the first terms in each one. We have a times a. Then we multiply the outside terms. A times negative 3. Those are the terms that are on the outsides. Then we multiply the inside terms. That's negative 3 times a. And finally, finally, we multiply the last terms, so the last ones of each binomial. -3 times -3. Okay, so we've set it up, but now we need to actually multiply all these. And so we get a times a is a squared. A times -3 is -3a. -3 times a is also -3a. And -3 times -3 is +9. Then we take all these and we add them up. So we have a squared plus -3a plus -3a plus 9. All right, so -3a and -3a are like terms. They're going to combine to give us a squared minus 6a plus 9. But remember, this just goes back into here, and we have to finish solving still. So this part of our equation simplifies to a squared minus 6a plus 9, and then we have to bring down minus 5. So now we can combine like terms here, and we get g of a minus 3 is equal to a squared minus 6a plus 4. And that's your answer. So I know that one looks a little different than all the other ones we've done so far. I wanted to make sure that you had some guidance on how to do that. And just to be clear, if we had been using the f function here, you would have put a minus 3 in for x, and then you would have had to distribute. So it would be -4 times a minus 3 plus 9. So you would distribute that -4 and then combine like terms. All right, you guys go and finish all 20 problems. I've given you several of them in the video, but you do have to write down all 20 problems and answer them completely. Have a great day.